All right, so this week I'm giving you a chance to practice and review operations with radicals, which is what we've talked about the last 2 weeks. So for this video, what I'm gonna do is I chose a few of the problems that either I got a lot of questions on or I saw a lot of mistakes on. And instead of addressing each one of you individually, I'm gonna talk about them to all of you in this video. So here's the first problem that some of you had some issues with. So it's the square root of 7 minus 6 square root of 7. All right, pretty simple one. This one's a really easy fix. So if the number or the amount under the radical is the same, it just stays the same. All right, what I saw a lot of you do was say that the answer was -6 square root of 7. So the reason that that's not true is because in order for that to be true, there would have to be a 0 right here. Well, if there was a 0 right here, 0 times the square root of 7 would be 0. So this wouldn't actually be the square root of 7. What we have to do is assume that there's a 1 here. Just like we do with variables, like if we have x, we can assume it's 1x. We do the same thing here. Instead of just the square root of 7, we can do 1 times the square root of 7. So now you can just subtract your outside numbers. 1 minus 6 is -5. So -5 square root of 7. All right. If you still have questions, you're more than welcome to email me about it, but hopefully that clarifies. All right, the next one that I saw some issues with, we have the square root of 27 plus 2 square root of 3 minus the square root of 12. All right, so for this one, the numbers under the radicals are not the same, so we can't just combine them. We're going to have to simplify, and in order to do that, we're going to have to factor. So 27, I'm going to draw a factor tree, and I'm just looking for 2 numbers that multiply together to get 27. So I can use 9 and 3. 3 is a prime number, so it's as low as it can go. 2 numbers that multiply together to equal 9 are 3 and 3. Again, those are prime. Once you get to all prime numbers, you know you're done. Now I can rewrite, instead of the square root of 27, I can say it's the square root of 3 times 3 times 3. You're looking for pairs, so here's a pair of 3s, and I can take them outside the radical. So the 3 goes on the outside since there was a pair, and then there was still a 3 left on the inside, so we still have a 3 on the inside. Now that's just for this first part. Second part, it's already simplified. We don't need to do anything to it. So I'm going to say plus 2 square root of 3. All right, we've got to simplify this last one. 2 numbers that multiply together to equal 12 are 4 and 3. 3 is prime. 2 numbers that equal 4 are 2 times 2. 2 is prime. So when I rewrite this, 2 times 2 times 3, I just used my prime numbers. I'm looking for a pair. All right, there's a pair of 2, so that means 2 can go on the outside. So I'll have 2, and then the 3 stays on the inside. This was subtraction, so I'm going to do minus. Now if you see, inside the radical is all the same. So, okay, I know my answer is going to have radical 3. Now I just combine the outside numbers. 3 plus 2 is 5, minus 2 is 3. So my final answer is 3 radical 3. All right, I'm going to show you one more problem, but it's kind of long, so I need to pause this and write it out. All right, here's your long one from last week. I am going to warn you that this takes a lot of different steps. I know that. I'm going to do the best I can to keep this organized and to go through it pretty slowly. Okay, so the first thing you're going to do is you're going to take the first term. So I've got 5 square root of 2. And I'm going to multiply that times this entire second parentheses. So I've got 5 square root of 2 times this whole parentheses. So 2 square root of 10 minus 5. Okay. That's my first step. And then I'm going to take this plus sign and put it right here. Now I take this entire second term and also multiply it by the entire second parentheses. So 3 square root of 5 times 2 square root of 10 minus 5. Now again, we're going to have to distribute everything outside the parentheses in here. So we're going to have to do the distributive property twice. What I'm going to do to help myself stay organized is I'm just going to kind of draw a line right there just so that you can see that if it's on this side, it came from these numbers. And if I write it on this side, it came from those numbers. You don't have to draw the line. Again, it is just so that hopefully I stay organized enough for y'all to follow along. All right, over here, we're doing just regular distributive property. So I've got 5 square root of 2 times 2 square root of 10 right there. This minus sign is just going to come right here. And then I've got 5 square root of 2 times 5. So all I did was took this outside number, distributed it by the first term, and then distributed it times the second term. And I'm going to go ahead and simplify all of this first, and then we'll go back and do the same process on that side. All right, so right here, remember when we're multiplying radicals, we can multiply the outside numbers times each other and the inside numbers times each other. So 5 times 2 is 10. And then radical, the inside numbers 2 times 10 is 20. Bring my minus sign down. And then my outside numbers, well, this doesn't have an outside number, so just my whole number times the outside would be 25. And then keep the radical 2. All right, 20 can be factored down, so I'm going to go ahead and do that. 5 times 4 equals 20. 5 is prime, but 4 can be factored down to 2 times 2. So when I rewrite this, my outside number stays the same. And instead of radical 20, I'm going to put these three numbers. So 5 times 2 times 2. 2 times 2, that's a pair. So that can be taken to the outside. So if I take 2 to the outside, 10 times 2 is 20. And then I have 5 under the radical. And then I still have this term up here, so still minus 25 radical 2. Those cannot be combined or simplified any farther. So as far as this side is concerned, this is as far as we can go for now. And then remember, we're going to add whatever we simplify this side down to. So you're doing the same exact distributing, and then we are simplifying. So we're going to do 3 square root of 5 times 2 square root of 10. That minus sign comes down. 3 square root of 5 times 5. Same thing we did to the other side. Multiply your outside numbers. 3 times 2 is 6. 5 times 10 is 50. So that's inside. Bring this minus sign down. 3 times 5 is 15. Radical or square root of 5. All right, 50 can be simplified. So we can do 10 times 5. 5 is prime. Then 10, we can do 2 times 5. Both of those are prime. So my outside number is still 6, but under the radical, we've got 2 times 5 times 5. 5 times 5 can be taken out. So we're going to do 6 times 5 is 30. And then radical 2. Then we still have this term minus 15 radical 5. All right, so now we've simplified down to this equation down here. And now I can just start combining anything where the numbers inside the radical are the same. So I've got 20 radical 5, and I've got minus 15 radical 5. So I can go ahead and combine those together. 20 minus 15 is 5 radical 5. So that means this one's gone, and that one's gone because I've simplified them. And I've got minus 25 square root of 2 plus 30 square root of 2. Well, if I combine those together, I get a positive 5 square root of 2. So that one's gone, that one's gone. This is what we're left with. The numbers inside the radicals are different, so they cannot be combined. So that would be your final answer. And yes, I know it's a lot of work to get there. That's why I only gave you one of them. But that's how you do it. If that still doesn't make sense, shoot me an email. I can try another video, but this is about as broken down as it gets. I miss y'all, and hopefully this helped.